In this video, I will show you how to modify and compile your own version of Swift. And by that, I mean diving into the actual Swift language codebase. As you might know, Swift is an open source language and anyone can contribute and experiment with it. In my case, I wasn't expecting to make this video. In fact, I was working in something about how random numbers are generated in Swift, but I decided to go a little bit deeper into how random numbers are generated in the source code and trying to understand that. But for that, I tried to download the source code and figure it out by myself. But it turns out there's not so much documentation out there explaining how to do this process. And well, here I am trying to create a video and explain you this the more approachable way possible. But before moving on, I would like to clarify a few important things. First, I'm not an expert on this. The steps I will show you might not be the most optimal, but they worked for me. You also need to tweak some settings in your local machine, so proceed carefully and watch the entire video before trying it yourself. Second, this video is for local experimentation only. If you're looking to contribute to Swift repo regularly, that will require additional knowledge out of the scope of this video. Third, compiling Swift requires a lot of disk space. It's recommended to have at least 150 gigabytes. Trust me, I learned this in the hard way, running out of storage multiple times. Fourth, RAM is also important. In this video, I'm assuming you use macOS. Make sure you have at least 8 gigabytes, but to be honest, 16 is recommended. And lastly, this video will walk you through every step with detailed explanations. But if you want to skip straight to the point, check the description below for a summarized article. Alright, let's get started. The first step, of course, is cloning the Swift repository to your computer if you haven't done so yet. I recommend you to keep all your Swift work in a dedicated folder. In my case, it will be swift-source. Next, let's run the following command. It will automatically clone and configure all the necessary repositories required to build Swift. For example, LLVM, and CLang to support compilation, core libraries such as Foundation and Ground Central Dispatch, and many more tools. Now we'll have to download the following dependencies. The latest version of Xcode. It will install and provide a lot of useful resources for compilation and execution. In my case, I'm using Xcode 16. And from terminal, let's install the following dependencies using brew. Let me explain. CMake is a tool that helps to set up and organize how your code is built, like a blueprint of compiling projects. Next, we have Ninja, which is a super fast builder that takes a blueprint from CMake and quickly compiles your code. And lastly, we have SCatch, a tool that catches your code builds. So if you build the same thing over and over, this will make it much faster. Once done, let's finally review if the dependencies were installed correctly using version command. CMake should print 3.24.2 or higher version. Python should be at least 3.6, and Python is essential for running the build scripts. For Ninja and SCatch, just make sure version runs correctly. Lastly, if your Mac is running on Apple Silicon, ensure all the installed dependencies are built for ARM64. You can check this by using this command. For example, Python should show ARM64, otherwise Swift won't compile. Okay, that was a lot of preparation, but there is one more thing we have to do, but I will leave it at the end. For now, let's dive into the code. Swift code contains a lot of pieces, like the compiler, parser, and many more things. But to get started, for this demo, I will make a small update in the string struct from the Swift standard library. To do that, let's find string.swift file from this path. Swift, stdlib, public, and core folder. Here you will find a lot of familiar names, as array, bool, dictionary, and many more objects that are part of the Swift standard library. Let's proceed to open string.swift using VS Code, not Xcode. This will be our IDE to work through the rest of the video, and I will explain why at the end. But to keep it short, it's way faster and easier for you right now. Make a room and insert this extension. I'm happy adding this message, but feel free to write whatever you want. Now save the file, and it's time to build our custom library. To do that, let's run build script in the terminal. What this command does is generate a custom Swift toolchain with optimization, debug information, and assertions using Ninja as the build system. And if you're wondering what a toolchain is, it's a collection of tools, libraries, and utilities that work together to support Swift development and compilation. This build configuration is described in the Swift documentation, and I'll leave a link in the description below. I'll also explain more about toolchains in a future video to keep this one concise. For now, just keep in mind that this command will build your new version of Swift. It's now a good time to bring your coffee because this will take a lot. My Mac that runs an M1 chip and 32GB of RAM took around 2 hours, so yeah, you will have to do something else in the meantime. And don't forget the storage because that thing will consume around 50 or 60 gigabytes. Alright, see you later.
2 hours later.
Once this build process is complete, you'll have a new folder like this, with all the binaries to compile and execute a custom version of Swift. Yay! However, if you got any build issue, please take a look to the troubleshooting page that I will leave in the description below. Okay, it's finally time to test what we have done in the new project. To keep it simple, I will create a single Swift file called demo.swift, and I will add the following code calling the new Swift and tips property that I created earlier. You can save this file anywhere, but in my case, I would save it inside of Swift source folder. Now it's time to compile the file, but first, let's compile it using the default Swift version from Xcode. To do that, open the terminal and use the following command. We use xrun here to simplify a lot of linking and toolchain setup in your compilation process. Swift-C is the actual compiler that will transform the source code into an executable. If you press enter, you should expect an error because Swift and tips doesn't exist in the standard library. Now let's change the compiler from the one we generate with build script. Replace Swift-C from the one in this folder. This time, we should see any issue. It's finally time to run the executable. Let's run it using .dash command and... Wait, what? The compilation would succeed, but for some reason the execution is crashing and not finding Swift and tips variable. Why? This is the final step I mentioned at the beginning that we need to complete. And believe me, this info is gold for you because I spent days, if not weeks, figuring this out. I would really appreciate your like and subscription at this point. Thank you. The problem is that we compiled Swift using a custom compiler, but at runtime, we are executing this code linking the default Swift libraries from Xcode. The key to figure this out is right here. Swift is expecting that Swift and tips variable is at this location, which is the default location of Swift standard libraries core objects. But this variable is at a new location, the one from build-ninja blah blah blah. How can we tell Swift to look at the right library? To make this happen, we'll have to update the dynamic linker library path using this environment variable. Type this command in the terminal and you will see this location set. Just remember that this dynamic library path is set at the local section of your terminal. If you open a new one, this variable won't be set and the execution will try to link the default libraries again. Now try executing demo again and let's see the result. Congratulations! You have learned how to configure and run your own custom version of Swift. Yay! In this video, I tried to summarize my experience debugging and configuring a custom version of Swift. I honestly wasn't expecting to reach this point, but one thing brings me to another, and here I am sharing something that I'm pretty sure will help many of you out there. Of course, this is just a small piece of everything you need to know to actually contribute for real in Swift language. If you want to learn more, I will leave a lot of links in the description below. And let me know if you want to learn more about contributing to Swift or any other topic related to customizing Swift versions, because I really love it and I think we can explore more together. Before wrapping up, there's just one more thing. Why did I use Terminal instead of Xcode? Here's why. Technically, there is a way to edit the Swift source code by generating an Xcode project and compiling it from there. However, I encountered a lot of issues with this approach and I'm still investigating the problems. I also learned how to download an experimental version of Swift from swift.org, but to use my own custom build, I had to manually copy files to create my toolchain. I'm aware this might not be the best way to do it, but the most critical issue was dealing with the dynamic linker library path in Xcode. Unfortunately, I haven't found a way to resolve this yet. As I said, I'm learning as I go. Alright, that's all for me. My name is Pete, and this is Swift and Tips. Thanks for watching, and have a great day.